Hello, my beautiful AP CSA students. Welcome to another lesson in Unit 4 Data Collections. We are now on to Lesson 13, where we're going to be talking about implementing two-dimensional array algorithms. So we've covered two-dimensional arrays, we've covered what they are, and we've covered how to traverse them and display some stuff. But now we're going to get into talking about algorithms that we most commonly use with two-dimensional arrays. So go ahead, grab your notes, get settled in, and let's go through this content together. Okay. So creating an algorithm for a two-dimensional array, when we are using a 2D array algorithm, we have to use nested loops to traverse through the array. Whatever we want to do with that two-dimensional array, we have to use those nested loops in order to do that. Now, most of the algorithms, it's just easiest to do it in row major order, to start with the first row, look through one row at a time, and then go through column by column. But there's some algorithms that you will need to traverse in column major order. So when you're reading instructions about an algorithm you have to write, you really want to pay attention to, does this matter? And again, most of the time it really doesn't, and you can just do row major, but there are some situations, and you'll see one today, where it does matter, and you are going to want to pay attention to that, okay? Now, a lot of the algorithms we've applied with one-dimensional arrays and array lists, we are going to be able to apply them to two-dimensional arrays as well. We just have to have a nested loop thrown in there instead of just a one loop situation like we would with 1D arrays or array lists. So just know that we're going to cover three algorithms today, the three most common that are named in the CED, but you might have to also apply some of the algorithms you've learned before to two-dimensional arrays as well. Okay, so let's get into checking out this first algorithm.
Let's start off with a popular one, the linear search. Now, we kind of did something like this in the last lesson, but we're actually going to write the algorithm for it and write a method for doing it. Okay. So some things to keep in mind with the linear search here. Just like a one-dimensional array, here you are searching through an array for some sort of value. Okay, you're looking for a value in this array. So when you look through a value, in a one-dimensional array, we had to keep track of the index, but in the 2D array, we have to keep track of both the row and column index. Right? So if we want to see if there's a value we are searching for, we have to keep track of two things to represent the location of it. Now, because you have to keep track of two things, and if you want to know the location of it, you can't return more than one variable in a method. So a lot of the times the directions will ask you a couple different ways. Maybe just returning the column index or returning just the row index of what you're looking for. It might ask you return them both together in a one-dimensional array, because you can return a single one-dimensional array with those two items. It might ask you to return nothing and just print the location. It might ask you to return it as like as a string, right? There's a lot of different ways they could ask. So read the directions carefully to know what do they want you to return in this linear search, or even like a Boolean, true, false, did you find it or not, right? A lot of different ways to ask. Listen to the instructions and do what they tell you to do, okay? It's not going to be the same algorithm for every set of instructions. Now, for a searching algorithm, it really does not matter if you go through the rows first or the columns first. You are going to look through the whole array. So row major, as I've been saying, is usually just the preferred way of doing it. But is it wrong if you do column major? Definitely not, okay? But you could do either. Okay, so here's the instructions for this this particular algorithm we're going to write. Again, it's going to change slightly depending on your instructions, but here's an example one. Okay, it says write a method called linear search 2D that accepts a two-dimensional array of integers and a value you are looking for. So there's going to be two parameters here. The method should return a one-dimensional array with the row and column index the value was found at. It should return an array of -1, -1 if the value could not be found. Perfect. That's all we need. That's all the instructions we need, and we can put together a pretty little method from there. Okay. So first, let's start with the header here. Now remember, on the AP exam, if you're taking the AP exam, The free response questions where you are writing methods like this, they have points set out in advance, 9 points total for, or usually 9 points total, for this problem. So there's specific things that they're looking for that are going to grant you points. So like this might not be 9 points total, it might be like 3 of the possible 9 points, but they are looking for specific things to give you credit for. So there's some free response problems where you'll get a point just for writing this. So I need you to make sure that you are trying your best to write out as much as you can when it comes to writing these methods on the AP exam. So this header, you can see I have 2 parameters. Okay. One is a 2-dimensional array, I'm just going to call it matrix, and the other one is the value that I'm searching for in the matrix. It's going to return a 1-dimensional array that's going to be essentially like an ordered pair almost of the row and columns where that value is found at. Okay, and for some questions on the exam, you will get a point just for writing that out. Okay. So please, if you got to start small by just writing the header, start small. Okay, what do I need? I need to define a 1-dimensional array. I'm going to call it result. And I'm going to define it as -1, comma 1, so 2 values. And then you'll notice at the bottom I put return result. So if I don't find what I'm looking for, I'm going to be already returning -1, -1. Okay. This is another example of you could earn a point just by doing this, okay, depending on the rubric and the problem itself. But there are ways you could just earn a point just by writing this, okay, defining it and then being able to return it. Okay. All right, let's get into looking through that matrix. It doesn't matter which way you're going, so I will do row major. And I said you're going to be looking at these headers long enough. Hopefully they'll just come naturally to you. But those are your 2 headers for row major. I is going to be rows, K is going to be columns. And you're just going to look through the whole 2-dimensional array. Okay. What are you going to check? Well, you're going to ask a question. At each element, you're going to see if that element is equal to the value you are trying to find. So this question looks like an if statement. If the element you are currently at, matrix I, K, is equal to the value which you are trying to find, what are you going to do? Well, you want to put the location of the row in the column into result. So result 0 represents the row index and result 1 represents the column index. Okay. And you're done. Right? Because you'll return result. Now notice that this actually does loop through the entire 2-dimensional array before something is returned. So that means if this value is repeated anywhere, okay, let's say you're searching for the value 2. Okay, let's say I want to find 2 in here, right? The first time I'm traversing through row major, I found it, right? But it keeps traversing through. Oops, found it again. So result, this would change again because you're looping through. And then, oops, I found it again, traversing through. So what actually would get returned would be this value right here, which maybe is what you wanted. Okay, the directions weren't clear, but this algorithm we wrote would return the last occurrence if we're traversing through in row major order. Okay, if you wanted to return the first occurrence, you could have just put a return statement right in here in your if statement, so that as soon as that if statement was hit, you returned it. If you wanted to return this occurrence, you would have had to be a little bit more crafty, I guess, and actually known it was there. But usually it's either first occurrence, last occurrence. So just pay attention to the instructions there, because that's going to change this method slightly if the instructions are specific, which is what the AP exam will be. They will be very specific. Okay. Next algorithm, second of 3. Again, we're only going to go over 3 in these sets of notes, just to kind of practice a little bit. Sum up values. So in this algorithm, you're going to add up all of the values in the matrix. 6 since you're adding up all of the values, again, it doesn't matter if you go through columns or rows first, either way. You might be asked to find just column sums or row sums. And actually, no, we're not. That's in the homework. In the homework, you're going to be asked to do that. But you might be asked just to find column sums or row sums. So make sure you're paying attention to what the problem is asking. Here, it's just all of them. So again, doesn't matter, row major, column major, just do it. Right? So write a method that adds up all the values in a two-dimensional array and returns the sum. So I'm going to start off with my favorite method header here. It returns an integer that represents the sum. I assume it's going to be passed a matrix, so I have a two-dimensional array parameter there. I need a variable to keep track of what the sum is. So I just called it result. You could call it sum, but just called it result, and I'm going to return it at the end. Pause if I'm going too fast, by the way, and you need to write down code. So again, didn't matter what order I did it in. So here's my row major headers, right? Outside loop is the rows, inside loop is the columns. And then each time I go through, I take the element that I'm currently at and I just add it to result. Okay. And then at the end, I return result. It's a good time. It's a good time. That was a nice one. Oh, no, I did ask it in this notes. Write a method, okay, that locates the row with the largest sum in a 2D array. This method should return the row index that has the largest element sum. So you're going to add up all of the elements in a row and then return which of those is the largest, okay? And then there's a little note there that says, remember, we cannot assume that all values in the matrix are positives. And I'll explain why we have to keep that in mind here in a moment. But this is going to be a slightly bigger problem here because we have to keep track of a lot of things. Let's start off with the header. Okay, I'm only given a matrix, a two-dimensional array. Okay, and then what I want to return is the row index with the largest element sum. So I need to define a few variables here. Okay, I first need the sum of the row, so I'm going to define a variable called sum. I'm going to define a variable called row index max. I'm not going to set it equal to anything right now. I don't really need to. You could set it equal to 0, I suppose, if you want, but it'll be changing as I go through. Okay. And then I also need to keep track of what the row max actually is. Okay. And here's where I say, remember that we cannot assume that all values in the matrix are positives. So row max, if I set that equal to 0 and all of the elements were negative, row max would still be 0. Okay. And that would be a problem with my algorithm. So because my instructions specifically say that we cannot assume all the values are positives, I'm going to set that equal to integer.min value. So I need to set it equal to something because I'm going to be adding on to it. But what that is, or excuse me, I'm not going to be adding on to it. I'm going to be putting in the row max in there. I need to set it equal to some minimum value. So even if all the values in the 2D array are negative, it's going to work out. Okay. Yep, there we go. Okay, now I've already done this. Okay, and actually I think row max, I think I actually misspoke. I think that's why I was getting a little confused here. This should be up here. No, the sum. No, I think that's right. I think that's right. Okay, no, I'm right. I'm right. You remember I talked about this in the other video. Is sometimes, no matter how many times you look at the code, you just kind of get turned around when you're looking at it for too long and doubting yourself. No, okay, so row max is going to be this because my first time through the loop, you're going to have, I'm going to set sum equal to the row max, and or I'm going to compare sum to row max, and the first time through sum will always be bigger than row max, as you're going to see in a minute. So the first time through, because it's always bigger, row max is going to be assigned the sum of the first row, and that's what I want. Okay? If I set row max equal to 0, if the first rows were all negative, then the sum wouldn't be bigger than row max, and I wouldn't enter that if statement. I'm getting ahead of myself though. Let's go back to my loop headers right here. Okay. I'm looping through the row with the largest sum. So because I'm looping through the rows, I want to go through in row major because I want to go through the entire row first to find the sum. And I'm going to traverse through the columns. Okay. And then I find the sum like I just found the sum in the last one, right? Sum plus equals matrix at the current element. Once I have that sum, this is what I was talking about earlier. I want to check to ask, is that sum greater than the row max? The first time through, it absolutely will be, and that's what I want, okay? That's what I want the first time through. But the next time through, it kind of depends, right? What's the sum of the row? If sum is bigger than row max, that means I have located a row that is now the new max, I guess, right? So I'm going to change two things. My row max becomes the sum. Okay, so that represents now the largest sum that I have found in a row. And then the index becomes I, because I represents the rows, remember. So that's the row where I found that max sum. Whew. Sorry, I hope we got back on course there. I don't mean to get so scatterbrained sometimes, but it happens to the best of us. And I'm not even the best of us. I'm just an average of us. So it'll happen. Okay, and we're almost done. But remember that sum needs to be reset to 0. Okay, has to be reset to 0 because I'm accumulating it here. Before I go back up and move to the next row, I need to reset it equal to 0. Okay. Woo. I think on your homework I asked you to do this same exact thing, but with columns. So enjoy that. All right. We're going to go be on our last algorithm here. Find column minimums. Okay. So in this algorithm, you're going to make a 1D array of minimum values in each column of the 2D array. Okay. The first element at index 0 in the array will be the minimum value found in column 0 of the 2D matrix. Whew. Okay, so what that means, let me draw that out real quick. I always love a quick sketch. Okay, so here are your columns. You're going to look through your columns and you're going to find the minimum value, okay, wherever that is. Once you find that minimum value, you're going to put that minimum into a one-dimensional array. Okay, so whatever that minimum is goes in that one-dimensional array. And what they're saying is that the indices, your column index, corresponds to the index of your one-dimensional array. So if my minimum's here in column 1, it's going to go here in index 1 of my one-dimensional array, so on and so forth. Okay, so that's what that means. Here, we do need to loop through one column at a time. Okay, this is where we are going to go through in column major order. We're going to fix the column and loop through the row. Okay, so the outer loop is going to go through the columns and the inner loop goes through the rows because of that. Here would be the instructions for something like this. Write a method that finds the minimum value in each column and records it in a 1D array where the index of the 1D array corresponds to the column index where the minimum was located. The method should return the 1D array of minimum column values. Perfect. Loop header. Dang it, I'm so confident. Method header. Method header is what I meant to say. Starting off, we got our matrix, our two-dimensional array, and we are going to return a one-dimensional array with all of those column minimums. Okay. So let's define a few variables first. That's our favorite thing. We're going to find a min, okay, where min is going to represent the minimum value in each column. Okay. And then I have a 1D array called min list, which represents my array. So I have to create the min list, and it's going to be the length of how many columns there are, right? So each column in the 2D array corresponds to the indices in the 1D array we said. So the length of that 1D array is just how many columns there are. So I wrote it like that. And then at the very bottom, you'll see I return min list, because that's what we're returning after all is said and done. Okay. Me so far? Okay. Almost done. Almost through this. I already decided that I want to fix my column and traverse through my rows. So my outer loop here, I just wrote the outer loop for a moment. My outer loop is going to be traversing through the columns. So you'll notice I have the matrix 0.length. Okay, so it's traversing through the columns. Now, here's where I get clever. So minimum, I'm going to define my minimum to actually be the very first element in my column. Okay, so that means if I have a column here, I'm going to start at column 0. Start at column 0, and I'm going to call this very first element my min. Whatever it is, it's going to be assigned to my minimum value. Okay? And then from there, I want to loop through the rest of my rows and compare it to that min. Okay? Now I do it this way because I need a new minimum each row I go into. Right? So each time I go into, each column I go into. Each column I go into gets their first element to be called their min, and then we go through the rest of the rows to figure out where the next one is. Okay? So that's why when I write my inner loop here, I'm actually going to start at k equals 1 because I've already defined that element 0 row as my minimum. Okay, the 0, row 0 is already my minimum. So I'm going to start at k equals 1 and traverse through the rest of my rows. Okay. So that's why k equals 1 here, and k goes through matrix.length, which is the number of rows that I have. Now, could you have started off k equals 0? Absolutely. Okay. You just would have had a 1 traversal increase. It's really not that big of a deal. Start off at k equals 0 if you want, but I only have to start off at k equals 1. And then I'm going to compare the element that I'm at, which is k as my row, I as my column, and compare it to the minimum. If it's less than the minimum, that means I've found a new minimum. So I take my current element and I assign it to my minimum. Okay. So I'm looking through the column, and this finds and records my minimum. Okay. Now what do? Once I've looped through my whole column, so I've gone through each row, traversed through the rows, I've reached the end of this loop, I have my minimum, I need to assign that minimum into my min list. And at location I, where remember I represents the column I'm on, which also corresponds to the index of my one-dimensional array. Yeah! A lot of good stuff, I want to bring up real quick, because I always get someone asking this question, why did we not use for each loops in all of these, right? So why can we not rewrite all of this code segment, or this one, for example, using a for each loop? Okay. Remember that a for each loop, one, it only works when trying to traverse in row major order. Okay, that is very important to note. Okay, it only traverses through in row major order. So you can't write a for each loop any other way. So in this example, we wanted to go through by column. and there's no way to write a for each loop to go through columns. You can only go through rows. Okay. The second reason, remember we said that for each loops are good for accessing, but they are not good for modifying or for remembering location. And here in this example, we wanted to keep track of the location. Okay. We didn't modify anything. I guess technically we did modify the min list, okay, but we didn't modify any of the elements in the 2D array. Okay, we just wanted to access them. And keep track of their location.
And that wraps up our lesson on two-dimensional array algorithms. Thank you guys so much for following along. If you have liked this video, please hit the like button and subscribe to my YouTube channel for more great CSA content. And until then, I will see you in the next videos. Thank you guys so much.